So I believe and I hope that everyone is sitting with a geometry box and everyone has done the homework. In the last lecture, we drew 3 ray diagrams for convex lens. And in fact, up till now, we've drawn 6 ray diagrams for convex lenses. In some ray diagrams, we get a real image. In the last ray diagram, if you can recollect, we get a virtual image. In some ray diagrams, we get an erect image. In some ray diagrams, we get an inverted image. In some ray diagrams, we get a magnified image, matlab bada image. In some ray diagrams, we get a diminished image, matlab chota image. And in one ray diagram, we get the image of the same size. Iska matlab, the bottom line is, in a convex lens, we can get all types of images. We can get real as well as virtual. We can get erect as well as inverted. We can get magnified, we can get diminished, and we can get the same sized image. Now today, what we will do is we will draw the last 2 ray diagrams for concave lens. So as I start my presentation, as I share my presentation with you all, I want you all to be ready with your notebooks and geometry box fast. Okay, right? So now pay attention, come on. After drawing 6 ray diagrams for convex lens, it is time now to draw ray diagrams for concave lens. But the best part is concave में 6 ray diagrams नहीं बनाना है. Concave में we only have to draw 2 ray diagrams. But यहाँ पे ना concave lens का basic चीज कैसे बनाने का? Let us have a recap once again. We draw a principal axis first. Just like convex lens, we mark 5 points. The centermost point, as you can guess, it is O optical center. अभी ये सब तुम लोग को ये टाइम पे मालूम होना चाहिए that right hand side वाला point is F2, राइट हैंड साइड वाला पॉइंट इज 2f2, O के लेफ्ट साइड में है F1, उसके लेफ्ट साइड में है 2f1. सबके बीच में हम लेते हैं 2 सेंटीमीटर्स का. Then at point O, we draw a vertical dotted line. The measurement of the line again is 3 centimeters up and 3 centimeters down. Now, how do we draw a cave lens? Now, this is something that we have to be very, ये मैंने last time भी सिखाया था, if I'm not wrong, but वापस से सिखा रहा हूँ. So pay attention. What you do is take a protractor. You keep the protractor vertically in such a way that 90 degree, look at this 90 degree of the protractor. It is falling on the principal axis. So the 90 degree mark falls on the principal axis. This protractor has to be held in such a way that it is slightly away from O. बहुत ज़्यादा दूर नहीं है, एकदम थोड़ा सा O के दूर होना चाहिए. And you trace a curve, thing like this. Then how do you draw the other side? To draw the other side, again keep the protractor vertically, lekin ulta. But again, 90 degrees should fall on the principal axis. And again, draw a curve. Once you finish drawing both the curves, you join the curve upper and niche, and you get your concave lens ka basic things. Now, I am sure majority of you all have 2 such diagrams because it was a part of homework. Few must have not drawn. So for those who have drawn, I am giving you 1 last minute. 1 minute draw 2 such diagrams. जो तुम लोग को स्क्रीन पे दिख रहा है, ऐसे 2 डायग्राम्स तुम लोग को बनाने हैं. 1 ही मिनट का टाइम दे. स्टार्ट. Those who have already drawn, you don't worry. Those who have not done the homework, please do it fast because without this, we can't see. Come on. Last 10 seconds, everybody. All right. Okay, chalo, now stop drawing, everyone. Look here, the question. The first question of concave lens ray diagram, actually diagram number 7 that we are drawing now. And the question is object at infinity of concave lens. Now children, if you can recollect, ऐसा एक डायग्राम हम लोगों ने कॉन्वेक्स लेंस के लिए भी बनाया था, ऑब्जेक्ट एट इंफिनिटी. Similarly, we are drawing now object at infinity for a concave lens. तुम लोग को याद है तभी मैंने क्या बोला था? Infinity means very, 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 very far away. And whenever the object is very, 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 very far away, we draw the object like this, beyond the principal axis. Only specifically for these type of ray diagrams, the object size will be 2 centimeters, 1 centimeter above principal axis and 1 centimeter below the principal axis. तो फटाफट टाइम यूज सम ऑब्जेक्ट बनाओ जल्दी. प्रिंसिपल एक्सिस के पीछे बनाना. Keep the size of the object as 1 centimeter up, 1 centimeter down. And name the object AB. Okay. Fine. So having drawn the object, now let's start drawing the ray diagrams and find the position of the image. अभी हमको में ये भी हम लोगों ने पहले किया है that whenever the object is at infinity, light rays come parallel. I have some light rays which are parallel to the principal. There are 2 rays of the principal axis, 2 rays below the principal axis. But तुम लोग 2 और 2 नहीं बनाओगे तो भी चलेगा. तुम लोग सिर्फ एक ऊपर और एक नीचे बनाओगे तो भी चलेगा. So what I'm doing is I'm giving you again some time to draw the parallel rays, but more importantly, you will draw the parallel rays only till the dotted line. All right. So draw some parallel rays of light which are parallel to the principal axis. Come on, fast. You can draw only one ray up and one ray down. That is more than sufficient. And after you finish drawing the rays, draw the arrow marks the way I have drawn. Okay. Come on now, stop drawing. So what we've done is we have first drawn the object beyond the principal axis, and then we have shown light rays coming parallel to the principal axis. Now children, this is a concave lens, and concave lens, ये हमने very first lecture में पढ़ा था, concave lens is a diverging lens. So that means the rays will diverge. Diverge का मतलब the rays are going away from each other. And when they go from each other, obviously there is no chance that they will meet on this side. ठीक है? बट सोचो अगर मैंने ये सब रेस को पीछे एक्सटेंड किया तो मिल सकता है ना. Let us try this. If I extend the rays behind, then they appear to meet at the focus, and this is the most important part. See, we have drawn parallel rays. It's fine. अभी इसको डाइवर्ज करना है, बट ऐसे ही डाइवर्ज मत करना. इंपॉर्टेंट क्या है कि पीछे एक्सटेंड करने के बाद फोकस पे मिलना भी चाहिए. तो व्हाट वी विल डू इज वी विल गो उल्टा. We will first draw dotted lines and then we will diverge them like this. ठीक है? I repeat, मैंने क्या किया? मैंने parallel rays बनाया, उसके बाद diverge नहीं किया. पहले मैंने dotted line बना दिया, so that now I know how to diverge the rays, so then diverge the rays. तो तुम लोग भी अभी ऐसे ही करो. पहले dotted line बनाओ और फिर उसको diverge करो आगे. Come on. Draw the dotted line, start from the focus, and then diverge the rays ahead. At the end of the rays, arrow marks. So having finished drawing the diagram, let us now discuss the position of the image and the nature of the image. Let's first start the position. सबको दिख ही रहा है, the point of intersection is here at F1. So that means the image is at F1. Nature of the image. क्या दिख रहा है तुम लोग को बच्चों? Rays are actually meeting or are they appearing to meet? Definitely they are appearing, right? That means the image is real or is it virtual? Yeah, correct. The image is virtual. Remember, the image is virtual. अच्छा, मैंने तुम लोग को एक रूल बताया था. If the image is real, it is inverted. Similarly, if the image is virtual, it will be erect. So that's why the nature of the image is virtual. It is erect. And look at the size of the object. So big. Look at the size of the image. It is just a point. So I'll use the word highly diminished. So the nature of the image is virtual, erect, and highly diminished. After you finish drawing the diagram, you take a pen and with the pen, write the question about the diagram and copy this position of the image and the nature of the image. Come on, fast. ऊपर क्वेश्चन लिखो, क्वेश्चन नंबर 7. Object at infinity of a concave lens. And niche, write the position of the image and the nature of the image. Position of the image at F1. Nature of the image, virtual, erect, and highly diminished. Come on, come on, come on, write fast. Okay, so I hope everyone has finished writing the question, writing the position of the image, nature of the image, and this brings us to last ray diagram number 8. And look at the question. Object between infinity and O of a concave lens. I repeat, the question is object between infinity and O of a concave lens. ये है basic diagram of a concave lens. See children, infinity is here, बहुत दूर. O is this. So when I say object between infinity and O, infinity इधर है, O इधर है, तो between infinity and O मतलब anywhere on the principal axis. You know, my dear friends, this is the best part about concave lens. You place the object anywhere on the principal axis, you will get the same type of image. Position भी same होगा, nature same होगा. So I will place the object anywhere. Now because I have placed the object between 2f and f1, जरूरी नहीं है तुम लोग भी वहां पे ही place करो. You can place the object beyond 2f, or you can place the object on 2f1, or you can place the object between f1 o. कुछ भी रखना है रखो. But you will place the object on the left hand side. You don't do it now. I will give you some time later on to draw. For now, this is your object. Come on, let's start drawing the rays now. Ray number 1. The first ray is the one which is parallel to the principal axis. But again, this is a concave lens. It is not a convex lens. तो ये जो ray है ना, वो ऐसे converge नहीं होगा. ये ray होगा diverge. And it will diverge in such a way that it appears to come from the focus. तो अभी तुम लोग बनाओगे कैसे, वापस देखो. पहले तुम लोग पैरेलल रे बनाओगे, उसके बाद you will first draw dotted line and then you will diverge it further, जैसे हम लोगों ने पिछले वाले डायग्राम में किया था. So that's your ray diagram, I mean ray number 1. Children, ray number 2 is still, the ray passes through the optical center and it goes straight without any deviation. You can see both the rays are intersecting at this point. And because the rays are intersecting here, the image is formed at that position. I name the image as A dash, B dash. Okay, position the image. You can see between which 2 points is the image formed. The image is formed between F1 and O. So I will write between F1 and O. Nature of the image. अभी तुम लोग guess करो. rays are actually being or appearing to meet? Definitely the rays are appearing to meet. देखो मैंने पीछे extend किया है. So rays are appearing to meet, and that's why the image is virtual. If you see the image, it is सीधा. So I will use the word erect. If you see the image, it is small in size. I use the word diminished. The nature of the image is virtual, erect, and diminished. It's a simple diagram, and now we will draw this diagram step by step. So first, assuming that everyone has this big diagram ready, we will first start with the object. तुम लोग को जहां पे भी ऑब्जेक्ट बना है वहां पे बनाओ. सिर्फ एक बात याद रखना, ऑब्जेक्ट का साइज 1 सेंटीमीटर, ऑब्जेक्ट के ऊपर एरो मार्क और ऑब्जेक्ट का नाम. कम ऑन, ड्रॉ द ऑब्जेक्ट. Okay, let's start with the first ray. The first ray is the one which is parallel to the principal axis. So draw this parallel ray, obviously with an arrow mark. Now this ray has to diverge. लेकिन diverge होने से पहले हम लोग एक dotted line बनाएंगे, फिर उसको diverge करेंगे. So draw this. End में again there should be an arrow mark. Draw the second ray as before, passing through the optical center, and it goes straight without any refraction. Now for me, both the rays are appearing to meet here. देखो मुझे point of intersection मिला, वैसे ही तुम लोग को भी point of intersection मिला होगा. Locate that point of intersection, and at that point of intersection you will draw the image. However small, draw it with a scale. Dotted बनाओगे तो भी चलेगा, straight बनाओगे तो भी चलेगा. But the image has to start from the principal axis till the point of intersection. मतलब वो principal axis से लेके point तक जाना चाहिए. Arrow mark बनाओ image के भी और उसको नाम दो, ऊपर E dash, नीचे B dash. Now then at the top write question और diagram के नीचे copy this position of the image and nature of the image. Copy the question at the write the position, write nature. So children, I started my lecture today by saying that in a convex lens rather, जो हम लोगों ने पहले बनाया, in a convex lens, we get all types of images. We get real, virtual, we get erect, inverted, we get magnified, diminished, same size, सब कुछ possible है. But check both the diagrams of concave lens. देखो दोनों में हमको virtual image ही मिलता है. इसका concave lens will only produce a virtual image. It can never produce a real image. दोनों भी diagram का nature check करोगे ना तो दोनों में image is erect. इसका मतलब concave lens always produces erect image. It never produces inverted image. और दोनों का last nature देखो, एक highly diminished, एक है diminished. इसका मतलब concave lens always form a small sized image. It will never form big sized image. तो याद रखना बच्चों, concave lens always produces virtual image. It always produces erect image, and it always produces small sized image. Children, what I'm doing now is I'm temporarily stopping my screen share because even I want to ask a riddle today. So I'm asking you all a riddle based on this concave lens. You can chat and you can write your answer, but chat it with me. Don't chat and answer to Dhruv sir. I don't want to disturb him. फटाफट मुझे chat करके लिखते जाओ, ठीक है? पहले question सुनो अभी ध्यान से. I told you concave lens always produces a small sized image. मतलब concave lens हमेशा छोटा छोटा इमेज बनाता है. तो ऑब्वियसली कॉन्केव लेंस ऐसे जगह पे यूज होगा जहां पे हमको हमेशा छोटा इमेज चाहिए. करेक्ट. तो ऐसा कौन सा जगह है? आई रिपीट माई क्वेश्चन. आई टोल्ड यू कॉन्केव लेंस ऑलवेज प्रोड्यूसेस अ स्मॉल इमेज. तो डेफिनेटली कॉन्केव लेंस ऐसे जगह पे यूज होगा जहां पे छोटा इमेज चाहिए. तो ऐसा कौन सा जगह है जहां पे हमेशा हमको छोटा ही इमेज चाहिए? घाटकोपर नील रावत हैज रिटन dentist. Beta dentist uses the lens. This is a mirror. Mirror is different. Lens is different. Grisha Shah Ghatkoper has written rare view mirror. Again the same thing. It is a mirror. वो 9th में हमने पढ़ा था. अभी भूल जाओ उसको. We are talking lens. Watch. I don't think watch के अंदर एक lens use होता है. People are writing mirrors, mirrors, mirrors. Remember, mirrors are different. We are talking about lens. माइक्रोस्कोप. बेटा माइक्रोस्कोप में छोटा इमेज चाहिए, हमको बड़ा इमेज चाहिए. माइक्रो ऑर्गेनिज्म का बड़ा इमेज देखना है हमको. सो इवन माइक्रोस्कोप इज रॉन्ग. मैग्नीफाइंग ग्लास. डोमिनिक हैज रिटन मैग्नीफाइंग ग्लास. मैग्नीफाइंग ग्लास भी गलत है बिकॉज मैग्नीफाइंग ग्लास में भी बड़ा इमेज बनता है, हमको छोटा इमेज चाहिए. सोचो. Come on, come on, come on, come on. I am not able to see the correct answer. Torch. What says torch? बेटा torch में भी mirror होता है. We are learning about lens. Come on, children. Binocular wrong. टेलीस्कोप. टेलीस्कोप में भी बेटा लेंस होता है. हम लोगों ने 9th में पढ़ा था. कॉन्वेक्स लेंस होता है टेलीस्कोप में. सिंपल. हमको बड़ा इमेजेस दिखता है स्टार और प्लैनेट्स का. Spectacles. People are writing spectacles. I will say spectacles partially correct. Partially, huh? Because not all spectacles may we require small images. Children, I'll do one thing. I think people have not understood the question. I'll repeat the question once again. Concave lens always forms a small size image. बराबर. इसका मतलब concave lens वहां पे यूज होना चाहिए जहां पे हमेशा छोटा इमेज चाहिए. तो ऐसा कौन सा जगह है? चलो मेरे ख्याल से मुझे ही आंसर देना पड़ेगा. I am not able to see the correct answer here. All right, chalo. Now I will give the answer. The answer is a simple peep hole of a door. दरवाजे के अंदर पता है एक peep hole होता है जहां से हम देखते हैं कि बाहर कौन आया है. The peep hole of a door is made up of concave lens because the peep hole always produces a small sized image so that we can see the entire face of the person who is standing out. So remember children, the peep hole of a door always has a concave lens. इसके बारे में हम लोग डिटेल में और आगे पढ़ेंगे. But again, I am starting my screen sharing with you all so that we can read further. चलो अभी सब बुक्स वगैरह सब बंद कर दो and just pay attention and understand whatever I am teaching. Come on, everybody. So we finished drawing ray diagrams, children. We understood that ray diagram is a method by which we can find out the position of the image. I'll tell you something, children. This method is a universal method. See, when I say universal means wherever you go, if we have to find the position of the image, we have to use this method called ray diagram. So it's a universal method. It is used everywhere. Now, children, something which is universal should have some rules and regulations. I mean, I not draw ray diagrams as per my whims and wills and wishes. I need to follow a set of instructions, or I can say I need to follow a certain set of rules. And the rules that we need to follow while drawing ray diagrams, पहली बार ये rules बनाया था एक scientist ने, और ये scientist का नाम था Descartes. Remember children, it's a French word, Descartes. S दोनों में silent है. It is not Descartes, it is Descartes. Descartes gives these rules for the very first time, and because the rules were given by Descartes, the rules are called as Cartesian sign conventions. Look at the word convention. The word convention means rule. The word Cartesian comes from the name of the scientist, Descartes. I don't know how many people can remember, but ऐसा कुछ तुम लोगों ने 9th में भी पढ़ा था, but those were the Cartesian sign conventions for mirrors. Now we are learning the Cartesian sign convention for lenses. Trust me, children, it is not at all taxing. It is all very, very easy. But to understand what the rules are, let us have one ray diagram in front of us for our reference. ये सिर्फ हमारे reference के लिए, हमारे example के लिए हमने ray diagram बनाया है. Let us start with Cartesian sign conventions. Rule number 1. तो बताओ जितना हमने ray diagrams बनाया, सब में object हमने कहाँ पे रखा था? Left side पे रखा था कि कभी right side पे भी रखा था? याद है ना, हमेशा ऑब्जेक्ट हमने लेफ्ट साइड पे ही रखा है. दैट्स योर रूल नंबर 1 चिल्ड्रन. द फर्स्ट रूल इज द ऑब्जेक्ट इज ऑलवेज ऑन द लेफ्ट द लेंस. इट्स अ वेरी सिंपल रूल. द ऑब्जेक्ट इज ऑलवेज केप्ट ऑन द लेफ्ट ऑफ द लेंस. कम ऑन, रूल नंबर 2. नाउ सपोज आई वांट टू मेजर द डिस्टेंस ऑफ द ऑब्जेक्ट फ्रॉम द लेंस. मुझे ऑब्जेक्ट का डिस्टेंस लेंस से मेजर करना है. तो यू नो आई माइट मेजर दिस डिस्टेंस, I might measure this distance. I might measure this distance. I can measure children different distances. और एक सिंपल लॉजिक ये है कि मैं अगर अलग अलग डिस्टेंस मेजर करूंगा तो अलग अलग वैल्यूज मिलेगा, और अलग अलग वैल्यूज मिला तो कंफ्यूजन होगा. And that's why there is a rule. The rule says that all distances should be measured from the optical center. जो भी डिस्टेंस मुझे मेजर करना है, it should be measured from the optical center. So if I want to measure the distance of the object, I will measure it like this, from the optical center. If I want to measure the distance of the image, I will measure it like this, from the optical center. The rule says that all distances which are parallel to the principal axis are measured from the optical center. Children, when I say parallel to the principal axis, I am talking about like this. All horizontal distances have to be measured from the optical center. Rule 3. The third rule is all distances measured towards the right O are taken to be positive, while those measured towards the left are taken to be negative. ये तो बहुत easy है. Distances which are measured to the right of O, O के right में जो भी distance measure हुआ वो positive, और O के left में जो भी distance measure हुआ वो negative. Let us understand with the help of an example. देखो ये ऑब्जेक्ट है, ऑब्जेक्ट. सपोज मुझे ऑब्जेक्ट का डिस्टेंस मेजर करना है, तो चिल्ड्रन ऑब्जेक्ट का डिस्टेंस कौन से साइड पे है? लेफ्ट साइड पे है कि राइट साइड पे है? डेफिनेटली लेफ्ट साइड. आई होप एवरीवन नोज लेफ्ट और राइट में डिफरेंस. सो दिस ऑब्जेक्ट डिस्टेंस इज नेगेटिव. चिल्ड्रन अगर मुझे इमेज का डिस्टेंस मेजर करना है, तो इमेज का डिस्टेंस इज ऑन द राइट हैंड साइड, सो डेफिनेटली इट इज पॉजिटिव. So all distance measured on the right side are positive, and all distances measured on the left side are negative. Similarly, children, all distances perpendicular to the principal axis and above it into positive, and distances perpendicular to the principal axis and below it are taken to be negative. Children, the rule says that all distance which is perpendicular, मतलब ऐसा, and above are positive, लेकिन all distance perpendicular and below are negative. Let us again understand this with the help of an example. Suppose मुझे ऑब्जेक्ट का हाइट मेजर करना है. बच्चों मेरे को बताओ ऑब्जेक्ट का हाइट किधर है? प्रिंसिपल एक्सिस के ऊपर है कि नीचे है? ऊपर है, so it will be positive. अगर मुझे इमेज का हाइट मेजर करना है तो क्या लगता है, प्रिंसिपल एक्सिस के ऊपर है कि नीचे है? नीचे है, तो इट इज नेगेटिव. तो याद रखना बच्चों, all distances on the right side are positive, all distances on the left side are negative, all distances above are positive, and all distances below are negative. And the last rule is the focal length of a convex lens is positive, while that of a concave lens is negative. Now I want you to imagine now, the convex lens is in front of you. Suppose यहाँ से parallel rays आया, left side से ऐसा parallel rays आया. Tell me, अगर left side से parallel rays आया, तो ऐसा converge होके यहाँ पे मिलेगा. Because the focus is on the right hand side, the focal length of a convex lens is positive. Similarly, for concave lens, it will be ulta, negative. So children, I want you to read all the rules with me. Cartesian sign conventions, it is a very, very important 3 marks. The object is always kept on the left of the lens. Second, all distances parallel to the principal axis are measured from the optical center. Third, all distances measured towards the right of O are taken to be positive, while those measured towards the left are taken to be negative. Then, distances perpendicular to the principal axis and above it are taken to be positive. Distances perpendicular to the principal axis and below it are taken to be negative. And the last rule is the focal length of a convex lens is positive, while that of a concave lens is negative. बच्चों, I am not teaching you anything new. ये सब तुम लोगों ने ना ग्राफ में भी पढ़ा है. If you can read the graph, x axis पे right hand side में हम लोग ऐसा positive numbers लिखते हैं, left hand side में हम लोग ऐसा negative numbers लिखते हैं, y axis पे ऊपर हम लोग positive लिखते हैं और नीचे हम लोग negative लिखते हैं. This is the same thing that we discussed. Right side any distance is positive, left side any distance is negative, above any distance is positive, and below any distance is negative. All these rules are called as Cartesian sign conventions. Now, having understood the Cartesian sign conventions, we need to understand few important formulas which are related to the lens. And trust me, all the formulas are very, very simple. In fact, the first formula itself is called as the lens formula. Now, what is lens formula? But your lens formula is a relationship between V, U and F. I repeat, मैंने बोला lens formula is a relationship between V, U and F. Now the question is, what is V, what is U and what is F? ये सब हमने 9th में पढ़ा है, अगर तुमको याद है तो. V means image distance. U means object distance. F means focal length. I repeat बच्चों, V का मतलब है image distance, U का मतलब है object distance, F का मतलब है focal length, and the actual formula that I am talking about is this: 1 upon V minus 1 upon U is equal to 1 upon F. So बच्चों, henceforth if I ask you what is the lens formula, you should tell me 1 upon V minus 1 upon U is equal to 1 upon F. Just for me, do one thing. Close your eyes, everybody. Close your eyes. Do not sleep. Only close your eyes and repeat the formula with me. Come on. 1 upon V minus 1 upon U is equal to 1 upon F. Very good. Now look at your screen and tell me, what does V stand for? Image distance. What does U stand for? Object distance. What does F stand for? Focal length. The second formula that we need to learn is something called magnification. And the symbol of magnification is capital M. Now, before I tell you the formula for magnification, इसका पहले ना हम लोग meaning समझते हैं. Magnification का मतलब क्या है? See, remember children, magnification is the ratio. As you can see in front of you, magnification is the ratio of the height of the image to the height of the object. एकदम simple definition है. मैं फिर से डेफिनेशन रिपाऊं, तुम लोग वो सिर्फ फॉर्मूला को देखो. मैग्निफिकेशन इज द रेशियो ऑफ द हाइट ऑफ द इमेज टू द हाइट ऑफ द ऑब्जेक्ट. नाउ लेट अस कन्वर्ट दिस इनटू अ फॉर्मूला. मैग्निफिकेशन का सिंबल तो मैंने बोला कैपिटल एम. कैपिटल एम इज इक्वल टू हाइट ऑफ द इमेज. बच्चों याद रखना, हाइट ऑफ द इमेज सिंबल है h2 and height of the object का symbol है h1. So the formula for m is m equal to h2 upon h1. I repeat the formula children, m is equal to 2 upon h1. बच्चों m का है ना और formula है, m is also equal to v upon u. So henceforth whenever we say this formula, we will say it पूरा. हम लोग एक साथ लेंगे, m is equal to h2 upon h1 is equal to V upon U. So that means we've learned two formulas now. The first formula is the lens formula. The second formula is magnification. Lens formula is 1 upon V minus 1 upon U is equal to 1 upon F. Magnification formula, M is equal to H2 upon H is equal to V upon U. So do one thing. Open your notebooks. Come on fast. Open your notebooks. और पे हम दो list of formulae. Write the heading list of formulae. Let us write all the formulae at one single place so that we can remember and we can revise whenever we want. List of formulae लिखो first. 1 upon V minus 1 upon U is equal to 1 upon F. हमको सिर्फ फॉर्मूला लिखना है और कुछ नहीं लिखना है. 1 upon V minus 1 upon U is equal to 1 upon F. अच्छे से leave a line right second. Capital M is equal to H2 upon H1 is equal to V upon U. So M is equal to H2 upon H1 is equal to V upon U. Okay. Now children, I'm skipping this portion and I will teach you this portion a little later. But for now, I want you to learn our formula number 3. And this formula number 3 is for finding a value. The value is called as power of a lens. Repeat children, the value is called power of a lens. अपने चश्मे का है ना कुछ नंबर होता है. हर चश्मे का कुछ नंबर होता है and that number is called as power of a lens. So let us first understand the meaning of power and then we will understand the formula for power of a lens. Now power of a lens के लिए obviously I consider a lens. Look at the type of lens. It's a convex or a concave lens, children? Yes, it is a convex lens. I consider one more lens. Again, a convex lens. Children, there are two convex lenses in front of you. But दोनों में फर्क दिख रहा है? This is thin and this is thick. Now for a thinner lens, I have some rays of light which are parallel. Obviously, the rays will converge. They will meet at a point. हम लोग वो point को बोलते हैं focus. अच्छा, obviously अगर ये focus है, तो ये वाले length को हम लोग देंगे focal length. Same thing happens to thick lens. Rays of light are parallel. Again they converge. Again ये वाले point को हम लोग बोलेंगे focus. Again ये वाले length को हम लोग बोलेंगे length. बच्चों, I want you to compare both the lenses and tell me कौन से lens में thin lens और thick lens. पहले question सुनो. कौन से lens में rays are bending less and कौन से lens में rays are bending more? Guess करो. कौन से lens में rays कम bend हो रहा है, कौन से lens में rays ज्यादा bend हो रहा है? I will tell you the answer. The answer is in a thinner lens. If you see, the rays are bending less. But thick lens में ना rays ऐसे जाके बहुत ज्यादा bend हो गया. ठीक है? So for a thinner lens, the rays are bending less. Here, the rays are bending more. So that means here I can say the rays are converging less. Here, the rays are converging more. मतलब the capacity of this lens to converge the rays is less. But the capacity of this lens to converge the rays is more. And this capacity to converge is called as power of a lens. So remember children, power of a lens का simple meaning है the capacity to converge. I repeat, power of a lens means the capacity to converge. Children, convex lens में मैंने बोला capacity to converge. तो concave lens में क्या बोलना चाहिए? Capacity to diverge. And that's how you form the definition. The capacity of a lens to converge or diverge the incident rays is called as power of a lens. So that means पतले वाले lens में power कम है because capacity उसका कम है. मोटे वाले लेंस में पावर है. बच्चों, आई वांट यू टू कंपेयर दोनों का फोकल लेंथ नाउ. दोनों का है ना फोकल लेंथ कंपेयर करो जरा. कॉमन सेंस है. यहाँ पे देखो फोकल लेंथ ज्यादा है लेकिन नीचे वाले लेंस में फोकल लेंथ कम है. बच्चों, कैन यू फाइंड अ रिलेशनशिप? पावर कम तो फोकल लेंथ ज्यादा, पावर ज्यादा तो फोकल लेंथ कम. इसका मतलब दे आर इनवर्सली प्रोपोर्शनल. And because they are inversely proportional, the formula for power is this. Ekdam simple formula. P is equal to 1 upon F. Remember children, the formula P is equal to 1 upon F. But I'll tell you something. This formula is very tricky. I can use this formula only when focal length is measured in meters. So अगर sum में ना focal length centimeter में दिया होगा तो we cannot use this formula directly. First we have to convert centimeter to meter and then we will use formula. So I want you to remember this formula in this manner only. P is equal to 1 upon F in meters. Note down. Come on, list of formula में लिखो. Formula number 3. P is equal to 1 upon F और F के बाद brackets में लिखो in meters. P is equal to 1 upon F in meters. I know people have started watching the time. I will not take more than 2 minutes now. Come on. P is equal to 1 upon F in meters. अच्छा, obviously focal length is measured in meters. Power का भी एक unit होगा. Remember children, the SI unit of power is diopter. I repeat, the SI unit of power is diopter and the symbol of diopter is capital D. तो अगर मेरे चश्मे का पावर है 1.5 तो it is actually 1.5 diopters. अगर मेरे चश्मे का नंबर है -2 तो it is actually -2 diopter. Remember, the SI unit of power is diopter. चलो now simple. Suppose there is one lens जिसका power is P1. Suppose there is another lens जिसका P2. अगर दोनों लेंस को मैंने मर्ज कर दिया, कंबाइन कर दिया, तो टोटल पावर कैसे ढूंढने का? सिंपल फॉर्मूला P equal to P1 plus P2. फॉर्मूला नंबर 4. नोट डाउन. कम ऑन. P is equal to P1 plus P2. अच्छा, हमको मालूम है P का फॉर्मूला है 1 upon F. वो मालूम है P1 का फॉर्मूला हो जाएगा 1 upon F1 और P2 का फॉर्मूला हो जाएगा 1 upon F2. तो अगर P का फॉर्मूला है P1 plus P2 तो 1 upon F का फॉर्मूला हो जाएगा 1 upon F1 plus 1 upon F2. Note down formula number 5. And the last formula of this lesson. 1 upon F is equal to 1 upon F1 plus 1 upon F2. Children, I will just repeat all the formulas. I want you to check. Please do not make mistakes while writing the formula number 1. 1 upon V minus 1 upon U is equal to 1 upon F. Formula number 2. Capital M is equal to H upon 1 is equal to V upon U. Formula number 3. P is equal to 1 upon F in meters. Formula number 4. P is equal to P1 plus P2. And formula number 5. 1 upon F is equal to 1 F1 plus 1 upon F2. Now remember, ये सब जो फॉर्मूला तुम लोगों ने है उसके राइट हैंड साइड पे कुछ तो जगह होगा. वो जगह पे है ना, जो भी मैं अभी डिक्टेट कर रहा हूं वो लिखते जाओ फास्ट. राइट. V, स्मॉल लेटर V dash image distance. That means V stand for image distance. Next line, U dash object distance. Next line, F dash focal length. Next, capital M dash magnification. Capital M dash magnification. Then H1, small h, H1 dash height of the object. Then H2 dash of the image. And last, capital P dash power of a lens. So बच्चों आज हम लोगों ने बहुत सारी चीजें पढ़ी. The first thing we understood was how to draw ray diagrams for concave lens. It always produces virtual, erect, and small-sized image. Then we understood the rules called Cartesian convention. Right side positive, left side negative, above positive, below negative. And then we understood 5 formulas which are in front of you. Now homework. Your homework is not to draw or write anything. Your homework, you will by heart this list of formula pit pat. Next lecture we are solving. I will be personally random people to tell me the formula. So you will have to by heart this formula along with the meaning of each and every alphabet. So I'm done for today, Dhruv sir.